Since it is an electron acceptor, right? Then Lewis base in the sense it is an electron donor. Yes, this concept is well known to all. Now, coming to the concept of coordination complex, we know that let us take a simple examination of coordination compound here. CONH3 6 Cl3. Right. So you know that here these are the ligands, right? These are the ligands, and how the coordination compound forms. The central metal atom here, the cobalt is a central metal atom. It accepts the electrons from the ligands, right? So so that it is called as a coordination compound. Am I right? Now, tell me which is a Lewis acid here in this compound and which is a Lewis base in this compound. Can you? Which is Lewis acid here? Yeah, very good, very good. So the CM atom is a Lewis acid because it accepts the electron. The ligands are the Lewis base, right? These are the examples of Lewis bases, and Lewis acids, the examples of acid means accept or not. Here they are having a pair of electrons, so it will donate. So these are all Lewis bases. Acceptor means it would have the place to accept electron. So like that, Cu2 plus, Fe2 plus, Fe3 plus, AlF3. So these are all examples of Lewis acids, which has a place to accept two electron. These are the examples of Lewis bases which are ready to give a pair of electrons, right? So Lewis acids are usually, what is that? Central metal atom, right, which accepts a pair of electrons. Lewis bases are usually, what will be? Yes, ligands. In the case of coordination compound, these are ligands. So put together, we call it as a coordination compounds. Am I right? Put together, we call it as a coordination compound here. Okay, now coordination complex. Right. So this can be divided into three types. One is positive complex, another one is negative complex, another one is neutral complex. Any guess how can we identify the coordination compounds as a positive, negative, and neutral compound? If I give you examples, you can understand easily. Cu NH3 4 times. This is under the square bracket. That is, this is a coordination sphere. You know, this is SO4. Right. Right. Remember, when this compound divides into two, what will be the charge of the complex? This is a complex, right? The things which are under the coordination sphere is called as a complex, right? Can you guess when this compound is dissolved in aqueous medium, what are the ions will be formed here? It will be divided into SO4, you know, the 2 minus. So the charge of this complex will be plus 2, right? So now the charge of the complex is plus 2. So this is called as a positively charged complex, right? This is called a positively charged complex. Let me give one more example to you. That is K4FeCN6. Right. Now, so this is a complex here, as you know, right? So when this complex is dissolved in aqueous medium, how it breaks on? So it will breaks on like this. Yes, plus 4, and here this will be minus 4. Right. So this complex shall be called as negative complex. Right. So this is a positive complex. This is a negative complex. And let me give you example for neutral one. That is NiCl3. CO4, where there is no counter ions. FeCO5. So where there is no counter ions. So this will exist in solution as a whole, right? This will exist in solution as a whole because this is a coordination complex will not dissociated in aqueous medium. So these are all the example of neutral complex. Neutral complex. For naming, we have to classify these things. We have to find out whether it is a positive complex. Positive complex means what we have to do? We have to write the metal name as it is, copper. Right. Negative complex means what we have to do? We have to add ATE to the metal name. So this is ferrous name. It is a negative complex name. So while naming, we have to write it as ferrate. Ferrate. We should not write ferrous. We should not write iron. So it should be written as ferrate. So for that, we have to identify whether the complex is positive or negative or neutral. So positive or neutral, we'll write the central metal atom as it is nickel, ferrous or iron, copper as it is we can write. For negative, along with the name of the central metal atom, we have to add ATE. Right. That is why we have to we are differentiating them positive, negative, and the neutral complex. Okay, getting into the core concept. Now, this is a point which we have to learn today, that is nomenclature of compounds. Note down carefully, nomenclature of coordination compounds. So let me get into the thing. Right, first point, first of all, always write the name of cation first. Note down with me. Always write the name of cation first. First of all, we'll make the heading as if it is a positively charged complex or neutral. Then these rules are applicable. So, first of all, find out the complex whether it is positive or neutral or negative. So, if it is positive or neutral, follow the rules. That is, if the complex is positively charged, first write down the name of the cation. Right. Second one, write down the number of ligands. I'll give you a few examples. Just no need, don't worry, just write it down. Then write the number of ligands. Right? Write down the number of ligands. Like that. Mono. Mono means one unit. Di. Tri. Right. Okay. But in the case of ligands already having the words like mono, di, tri. For example, ethylene diamine. Ethylene diamine. Here already there is a word di. So we should not write diethylene diamine. So in this case, what we have to do? We have to use the word bis. Bis means 2. Tris. Tris means 3. Tetrakis. Tetrakis means 4. Right? So these kind of notations to be used if there is another symbol indicating the numbers, right? Ethylene diamine, already the di is there, so we should not write diethylene diamine. Instead of write, we have to write bisethylene diamine, if it is true. If it is 3, it is called trisethylene diamine. If it is 4, it is called tetrakisethylene diamine. Right? Okay. Next, alphabetical order. Write the ligands in alphabetical order. Alphabetical order. Right. Let me give an example. Listen here. NH3, this is a ligand. We call it as amine. Right. And Cn minus, we call it as cyano. Right. So, if both the ligands are present in a compound, what we have to write? First, we have to write the name of ammonia, amine. A is first, and then we should go write the name of C. That is cyano. If NO2 minus, nitro ligand, if it is present in a compound, so what we have to do? This should be written as the last. Okay. So it should go as per the alphabetical order. Then there is a confusion here. Now, if amine is also called as A and there is another ligand called as H2O which we call as aqua. So if both the ligands are present, what we have to do? We have to go for the second letter. Right? Which second letter comes first? So this one. So first we have to go for amine and next we have to go for aqua. Right. This is a way to write the name of the ligands alphabetically. Okay. Fourth point, write the name of CM atom. CM atom followed by its oxidation state in bracket. Followed by its oxidation state in bracket. Right? For example, nickel 3, cobalt 3, iron 2. So like this you have to write. And finally, write the name of anion. That's all the rule. That's all the rule. Okay. Now, for the neutral ligands, there will be a slight change. Just now we are talking about the positive complex now. For the negative complex, here in the central metal atom, instead of writing the central metal name as it is, what we have to do, as I told you the earlier, we have to add ATE, right, in the name of negative complex. That's it. Let me list out the things once again. So first, what we are going to do? Yes, first write the name of cation and second write the name of ligand. First number should be right and then second ligand should be right. That should be in alphabetical order. That should be in alphabetical order. And third point, what's the third point? Ligand. After writing ligand, we have to write the CM atom. Yes, CM atom followed by its oxidation number in bracket. Right, oxidation number in bracket. And 4, write the name of the anion. That's all. So simple 4 steps. Right? So in the negative ligand, where is the change in the name of the central metal atom? What we have to add? We have to add AT. That's all. Right? So quite simple. Let us go for examples now. So this is a complex. First, we have to find out whether it is a anionic complex or cationic complex. Very good. It's a cationic complex because this is Cl is minus. So 3 minus means here there should be 3 plus and 3 minus. Okay. Right. Now, so what we have to do, as usual, first we have to go for the write the name of the cation. So this one we have to write first. So this part we have to write. So in this part, first we have to go for ligands. So in this ligand, as I told you, 2 ligands are there. One ligand is called amine, right? This is called amine, amino. This is called as amine. How many amine are there? Tri. So triamine. And this is called aqua. Yeah, how many aqua are there? Tri-aqua. Right. So among these two, which should be written first? Amine should be written first. So the name will be triamine, tri-aqua, and then here, what is this? Chromium. This is a positive charged complex, so that we can write the name of the chromium as it is. Chromium. Right. Now, what is the oxidation state of chromium here? This is a neutral ligand and this is also a neutral ligand. There is no charge for H2O. There is no charge for ammonia. So the total charge is that of the central metal atom. Right. So that is 3. So chromium 3 chloride. Is it clear? Triamine, triaqua, chromium 3 chloride. Well known example. This I get solved several times in our class. K4FeCN6. Right? So I had given the name of the class several times. So I'll give the clue. First we have to find out whether it is a positive or negative complex. Right? So this is a negative complex. Right? Because here 4 plus is there. So there should be 4 minus. This is a anionic complex. So what you have to do? You have to add ATE with the name of the central metal atom. That is a change. Just try it over. Hexacyano. Very good, very good. Good try, Kana. So that is potassium hexacyanoferrate. Very good. That is first the name potassium should be there. Right? Potassium hexacyano. Remember, we will learn while we are doing, because if you are going for the rules and regulations in deeper now, it will go almost 2 to 3 hours. So remember, note it down. When a negative ligand is there, we have to pronounce as O sound. We have to pronounce with O sound. So Cn is a negative ligand. So I'm pronouncing as cyano. Like that C2O4 minus is a negative ligand. I'll pronounce it as oxalato. Oxalato, cyano, oxalato, and NO2 minus, nitrito. So negative ligands whenever it comes, we have to add the sound O, cyano, nitrito. So potassium hexacyanoferrate, potassium hexacyanoferrate. So first of all, how many ligands are there? Amine is a ligand, aqua is a ligand, chlorine is a ligand. So chlorine is a negative ligand, that is Cl minus. So we have to call it as chloro. Right. This is chloro ligand. And another one is what is the ligand? NH3. That is amine. We call it as amine. And another ligand H2O. This is also neutral. We call it as aqua. So as we seen earlier, when amine is aqua coming together, amine should come first. So how many amine are there? Four amine are there. Tetra amine. Tetra amine. And then how many aqua? Only one aqua. So no need to write anything. Tetra amine, aqua, and then mono aqua, no need to mention ma, because if it is two na we can mention only one, just you can write tetra amine aqua. And here this can be written as chloro or chlorido, both are right. Chlorido, ido we can add or o we can add, chloro or chlorido, right? Chlorido, right? Next, what is the central model atom? Cobalt, right? Now, what is the oxidation state of cobalt here? Here there is 2 minus, here there is 1 minus. So totally there should be 3 plus inside. So the total charge of the complex should be 0. Na? Or else we can go in such a way that as usual we can take it as X and we can work it out. That method also we can go, but straight away we can go for here 2 minus is there, here 1 minus is there. So totally 3 minus are there. So it should be 3 plus. So cobalt 3 plus. So it is cobalt 3 chloride. So the name is tetramine aqua chlorido or chloro cobalt 3 chloride. Tetramine aqua chlorido or chloro cobalt 3 chloride. So here this is OH minus. So OH minus we got as hydroxyl, right? We got as hydroxy, right? So here we can add IDO. So instead of hydroxy, this one called as hydroxy, right? This is called a hydroxyl group, right? So we can call it as hydroxy plus IDO, hydroxido. So the name of this ligand is hydroxido. Okay. Now, next. Thrice. I think this you know. What is the name of this ligand? So oxalate is a negative ion, a negative ligand, so that we have to oxalate 2.